All right, welcome back. We are continuing on to section 4.2. These are a couple of theorems that are important, but not so much as to be a game stopper in a calculus class. These have much deeper implications, actually. We're going to start with Rolle's theorem. We're going to let f be a continuous function on the interval a to b, including the endpoints, and differentiable on from a to b, not including the endpoints. It could be differentiable on the endpoints, but that's not part of the theorem. And we have f of a equals f of b. Let's talk about what that looks like real quick. Let's do just a generic graph here. So that means that if we have a smooth curve, starting here, saying it goes up and it does whatever, and it ends up down here, where this is A and this is B, and we have the y value is the same. So this is f of A, and it is also f of B. So if we have a graph that does something like this, where f of a equals f of b, we're differentiable on all the points in between, and we're continuous on all the points in between, then there is at least one point, a point C, this is an x value C, between A and B, such that f prime of C is equal to 0, meaning its slope is equal to 0. And you can see we have at least one x value where the slope is equal to 0. And just to make sure so this is going to be C, that's between A and B. Now, the way a theorem works is you're given the if part, which are the conditions that need to be met. In this case, there are 3 conditions that need to be met so that Rolle's theorem can be applied. It has to be continuous from A to B, differentiable from A to B, and has to have f of A equal to f of B. If those 3 conditions are met, then we can conclude that there is at least one point C within that interval such that the derivative at that point is equal to 0. All right, let's apply Rolle's theorem here. Find an interval on which Rolle's theorem applies to the function f of x equals x cubed minus 7x squared plus 10x. Now, I want to point out this is what's called a cubic function. It's a polynomial, which means it's continuous and differentiable everywhere. And if you recall from your pre-calculus class, that this graph is going to have to look something like this. It's going to have to end down and begin going down and end going upward, because the lead coefficient is a positive 1, and we have a cubic, so we're going in opposite directions. Now, what I want to do first is I want to find out where the zeros are, meaning where this whole function equals 0, to get my interval that I'm interested in. So x cubed minus 7x squared plus 10x equals 0. I'm going to factor that. So it's looking to me like our graph is crossing at 0, 2, and then 5. So 0 is here, we'll say 2 is here, 5 is here. So our graph is doing something like this. We're crossing here like this, it's going up, it's crossing here, and then it's doing something like that. So I'm going to use the interval. X is going to go from 0 to 5. So that's going to be my Rolle's theorem, because all the y values are equal to 0. So we get that f of A equals f of B for sure. when they cross like that. So we're going to find all points on the intervals at which f prime of c equals 0. Now I'm expecting to find 2. So let's see. F prime of x, 3x squared minus 14x plus 10 equals 0. Now I'm going to have to apply the quadratic formula. Which is going to give me, let's go up here, we're going to get 14 plus minus the square root. Grab my calculator here. 14 squared minus 12 times 10, that's 120. So that's going to be 76 over 6. 76 is a multiple of 4, I believe, divided by 4. Yeah. So this becomes 14 plus or minus 2 root 19 over 6, which is going to further reduce, because I can reduce a 2 from all of those. It's going to be 7 plus or minus root 19 over 3. So here are my critical values. Now let's get an approximation of those. 7 minus root 19 divided by 3. That's getting me 0.880. And then 7 plus root 19 divided by 3. 3.786. And you can see both of those numbers are between 0 and 5. So it looks like we have a local maximum when x equals 0.880, and I could plug that into the original function to find out what the y value is, but I'm not all that interested. And this bottoms out here at x equals almost 4, so about right there. And when we plug that in, we're going to get a negative value, most likely. So Rolle's theorem is a theorem that is used to prove the mean value theorem. And we're not going to spend a lot of time with the mean value theorem. A lot of interesting things that you can do with it, but we're just going to go ahead and walk through this and do an example. If f is continuous, I'm here. If f is continuous from a to b, including the endpoints, and differentiable on a to b, not including the endpoints necessarily, then there's at least one point in the interval a to b such that, and here's the big conclusion here, f of b minus f of a over b minus a is equal to f prime at a point C. And I want to sort of show you graphically what is happening with this. This will have it make a little bit more sense. So if I have a function that's doing something like this, it doesn't matter. The point is, on the interval from a to b, we'll call a to b. What we're going to have is the slope of the tangent line at a point C. Let's mark that up. We'll call this C here. We'll call C here. The slope of the tangent line at C is going to have another slope that's parallel to it on that same interval. Where these two slopes are equal. As it goes through like that. So our conditions, we only have two conditions for the mean value theorem. It has to be, f has to be continuous on A to B and differentiable on A to B. So we are going to use the mean value theorem to determine whether the function f of x equals 2x cubed minus 3x plus 1 satisfies the conditions of the mean value theorem on the interval -2 to 2. And if so, find the points that exist by the theorem. So what we need to do is we need to state, first of all, f is continuous on A to B, and f is differentiable on A to B. And we know that because it's a polynomial, which makes it very nice for us. Okay, so we need to find f of -2 and f of 2. In this case, that's going to be 2 times -2 cubed minus 3 times -2 plus 1. And I got -9. And then +2. And I got 1. Let's double check that. So that's 8, that's 16 minus 6, 16 minus 6 plus 1, that's going to be 11. Yeah. And what that tells us is that I'm going to find the slope f of 2 minus f of -2 over 2 minus -2. So that is going to be 11 minus -9 over 4, which is 20 over 4, which is 5. So that's the slope of the secant line that makes up A and B. This means that according to the mean value theorem, f prime of x is going to be 6x squared minus 3, and we're going to set that equal to 5, the value that we just got here. And that is going to give us, that's 8 over 6, x squared equals 8 over 6, which is 4/3, which means x is going to be plus and minus 2 over √3. And if we get approximations for those, we're going to get 1.15 and -1.15. And you can see both of those are within this here. Here we are. And that is the mean value theorem and Rolle's theorem.